My slides visible?
Yes, it's visible.
Thank you. So, hello everyone. My name is Nidhi Goyal, and I am a PhD student at IIIT Delhi. And today I am presenting my thesis defense presentation on the topic improving content quality for online professional activities using domain-specific learning and knowledge. So, at the outset of it, I would like to thank evaluation committee members, Professor Mahesh, Professor Amit, Professor Maya, and my thesis supervisors, Professor PK, Dr. Raghua, and Dr. Niharika. So here is the outline of my thesis, and I will start with a brief motivation on online professional activities, and thereafter I will move on to the next part of my presentation. So there is, according to the Bureau of Labor Statistics, there is a massive increase in online professional, scientific, and technical services over the decade of 2021 and 2031. And on the major online professional platforms, job seekers, recruiters, and question askers, they post their unstructured content, and we have a lot of content in form of skills, work experience, companies, institutes. So naturally, we have a lot of content. We can see 830 million plus registered users. These are the statistics from a popular platform like LinkedIn. So naturally, content quantity is not the problem, but the quality is one of the crucial aspect when it comes to the people who are the consumers of this content. So quality naturally follows the value that the content creates after being put to use. It means the people who are used, if it does not serve their intended purpose, then it means that we are harming the quality of content, and that's where as so many activities are going on. Therefore naturally, so first issue is you would have seen that there is a lot of inconsistent content that comes across these platforms. So for an example, Dr. Baba Saheb Ambedkar Marthawada University, it has more than 1100 plus variations. Similarly, ICICI have 497 variations. The another kind of content issue comes when you see a job posting having some vague description, and you are not able to know that what kind of skills you need to apply for that specific job posting. Similar along the lines, there is a fraudulent content. So this is a post from a LinkedIn where a shuttle bus driver, it is being offered unusually high salary, and this kind of a misleading job which harms the platform reputation. And the lastly, we can see that there is a question which a knave or a beginner asks on any question answering platform. And this question has been closed by the platform moderators because of its low quality, and primarily the off topic because it is not relevant to the topic which the platforms deal with. Coming along these issues, we also face the challenges while dealing with these issues, that lot of unstructured content is there. Then we have a heterogeneous content. There is no context which is present. And finally, we do not have a domain specific knowledge. So in order to deal with these challenges, we ask the primary question that how can we improve the quality of online professional content by leveraging domain specific learning and knowledge. To answer this question, we have the following thesis contributions. So to solve all of these issues, I'll go through one of the contributions. So my first contribution is to deal with inconsistent content. So you may relate to it that there are a lot of non-standard entities that comes in day-to-day life when you face that there are spelling variations, and sometimes you use a lot of short forms over social media or any online professional platform. And then there are also a lot of entities which are not similar to each other, but they have some overlapping words. So when such content comes, then the question comes that is there a way where we can take all the variations of these entities and have a system which can tell us that look, these are the entities that belongs to the same these are the variations that belong to the same entity. So when we were looking into this issue, we came across many generic approaches because the problem is not new. There are a lot of inconsistent variations, but when it comes to domain specific data, these kind of generic approaches, they lack domain specific knowledge. At the same time, these kind of methods, they use statistical and word embedding kind of things where they find word overlapping, or they try to use some deep learning based techniques which fail to generalize over domain specific content. So towards this end, we proposed an architecture where we first prepared our data set. So we had a data set of entities, primarily skills, designations, companies, and institutes. So this data set, it was annotated by domain experts from a popular recruitment platform. So this data set contains positive and negative, this data set contains the annotated clusters, and from those clusters, we created positive and negative pairs. Using these pairs, further on, we trained our network, which is KCNet. At the top of it, we want to cluster all these entities in a specific, by using a specific algorithm. So these are our data sets statistics where you can see that there are huge clusters, and all of these clusters, they are not equal. So it might be possible that one entity, it has a very large cluster, and another entity, it could have only one entity in the same cluster. So their size clusters, they vary across, and similarly corresponding to it, we want to complement it with some kind of information that can help these entities to identify that they are referring to, whether we are referring to domain specific entities, and what kind of additional information that can actually help as a context for supplementing these entities. So we collected the side information from Wikipedia info box and Google KG. So this is our proposed architecture. So we started with the entities. We trained a entity embedding generation model. What does it do? It takes the entity as an input, and then it uses a pre-trained Stilbert model, out of which we get an entity representation. For the same entity, we collected the side information from Google Knowledge Graph and Wikipedia info boxes. Their corresponding side information, it is passed through the side information embedding generation model, and the two representation, they are concatenated together to introduce into the network, which is called as the kernel network. Now this kernel networks, it takes into account the concatenation, the dot product, the similarity of these two entities, at the same time, the difference, which is the L1 distance between these two entities. Finally, it is able to model the complex relationships and some patterns between these two kind of representations. Afterwards, the output, it is passed through the feed-forward neural network, and there is an output layer which will return the probability of two entities being similar to each other.
Nidhi, just one suggestion, if you could point on the screen, that would be nice.
Yes.
Yeah, you have the pointer right there. Yeah.
Yes. Thank you. So finally, from this model, we get a similarity matrix. So this was the pairwise similarity matrix that we get out of this KCNet. And these are our results. As compared to baselines, we can see that KCNet without side information and with side information, there is around 5 to 10% of increase when we include domain specific information. These are the results on our proprietary data set, and similar observations we have on open data set. So at the end of it, KCNet, it induces non-linear mapping between the contextual vector representation. With the help of KCNet, we are also able to identify semantic variations like mycology and fungi studies, because these are the variations which has some side information present in the Google Knowledge Graph, like that fungi is the study which is also called as mycology. So these kind of semantic variations we are able to model with the help of KCNet. And then at the same time, our model also makes mistakes when it identifies beeswax and natural wax as the same concept, but they occur in the different cluster. So that's where we ended up with the first contribution. In the second contribution, we want to find what is the incomplete content. So when it's a simple scenario, when a job seeker and a recruiter, they come on the recruitment platform, job seeker want to search for a job and the recruiter finally want to find some relevant candidate so that they can hire them. So when they post certain job posting on the platform, finally he get a less number of applies. Now the reason is unknown to the recruiter. Why is getting so less number of replies? So when recruitment platforms, they identify that these recruiters, they may or may not be domain expert. So finally the problem is that when they are writing a job description, they do not know what to write in the job description. Therefore, finally, this results in poor quality of job postings. And the more crucial problem that comes here is that 65% of these job descriptions, they miss mentioning skills, relevant skills. So therefore, we identified that skills are the crucial parameters due to which a candidate can decide whether I will apply for this job or I don't want to apply for this job. So in order to solve this problem, we can look into the scenario. So there is a job description, we have a job title. After that, we have a job description, which is unstructured content. And there are some required skills. So this is one of the section on the recruitment platform where you can choose that what are the skills I need. So recruiter has two ways to enter the skill, whether he can enter in the form of unstructured content or he can use required skills. So naturally we can see the data analysis and communication. These are the explicit skills which are mentioned in the job description itself. And rest of them are implicit skills, which he wants that a job seeker should able to identify from the unstructured content itself. So the problem here comes is that how would you take this job description and help a recruiter or a job seeker saying that these are the kind of the skills which you are missing in your job description, probably include, so that job seeker can get to know about that this particular job is relevant to him or her. So towards this end, we designed a job skill graph, which consists of 22,844 nodes. And then we also formulated and proposed a framework called JobXMLC, which learns this graph with multi-resolution graph neighborhoods. And finally, this graph network, which is JobXMLC, this was lightweight, and we are able to use it for the real-time systems. So what is the data set that is being used for this, for solving this problem? So the data set comes from mycareersfuture.sg. It's a Singaporean recruitment website, which has a 20,000 job postings, and we can see that total number of distinct skills are more than 2,500. The interesting thing here is that the number of skills with 20 or more mentions, they are only 1,209, whereas in the Stack Overflow jobs, it was only 50. So we can see that Stack Overflow jobs is more of a small scale data set where number of distinct skills are very less as compared to the Careers Future SG. So we took this data set and we first use this data set to have the job description and then required skills. First, we pre-process this job description using the pre-processing module. Now, this pre-processing module, it consists of POS tagger, and at the same time, it filter uninformative words, where we identified that in this job description, around 60% of the words, they are nouns. So, and most of the times, these nouns are mostly skills, which are mentioned. And also, when somebody posts job descriptions, they write something like requirements, experience. These kinds of words are kind of stop words for a job description, which will occur in all the job descriptions. So we also filter out those words. Once the pre-processing is over, then we construct a job skill graph. So the intuition behind constructing a job skill graph is to capture the connections between a job and a skill. Let's say if particular job, it needs some skill, and there is some another job which is also a similar category of job. For example, it is a data scientist job versus a data analyst job. Naturally, both the jobs will need a skill called as Python. So two jobs, they are connected via Python. It means we should be able to identify that probably these two jobs are similar, and the another job, if that misses that skill called as Python, then this network should be able to suggest. So finally, we construct this job skill graph where a job is connected to a skill if it is relevant to that particular job. And how did we identify this relevancy? Using the required skills. So this is already provided by the platform. In the second architecture, what we wanted to do, once a graph is constructed, at the first layer, we are trying to learn what are the immediate skills to that particular job. At the second layer, we are trying to learn that if I have these immediate skills, what are the jobs which are connected to these skills, so that I am able to find that these are the similar jobs. After that, I want to find that these are the similar skills. Means if a particular job which is connected to some other skills, then at the three hop, I should be able to identify that these are the similar skills. So this kind of network, it helps us to capture the transitive cues, where if two jobs J1 and J2, they share the common skill and a skill S2, which is also relevant to J2, we can infer that S2 might also be relevant to J1. So after this propagation network, since we see that in the data set we have a large number of skill labels, we naturally pose it as a extreme multi-classification task, where what did we do after this? We incorporated these embeddings, which are multi-resolution embeddings at each layer, and into the skill label specific embedding, where it generates a score for each label, which will tell me, so each label means each skill label, it will have a different view of the graph. So if there is a skill Python, it can have a different view of the graph versus a skill Java, it can have a different view of the graph depending upon what are the jobs it is connected to. So if two skills, they have a different label, then accordingly we can score these skills using one versus all classifier. And finally, we are able to identify that these many skills, these should be the part of a particular job, using recall at the rate 30 and precision at the rate 5, which is saying that in the top 5 how many skills are being captured. So in this we can see, as compared to all the deep learning based models and graph based models, JobXMLC outperforms over all the metrics. Similarly, this is for the Stack Overflow dataset. Here we can see that recall at the rate 30, it is less as compared to other matrices. The reason behind this is Stack Overflow, it has very few skills per for map to a particular job. That's why the denominator is always high. That's why the number is less for the Stack Overflow jobs dataset. In terms of comparison, because we wanted our network to infer at the real time, JobXMLC is naturally taking less training hours as compared to all the stronger deep extreme classifiers like BERT, where the prediction time is around 1200 milliseconds, and JobXMLC is just able to predict in the 1.89 seconds for both the datasets. So this is the quantitative analysis, where we see that there was a job description. This was the ground truth. BERT XMLC plus CAP, which was one of the baseline approach, it is able to predict some of the skills which are in purple. And job XMLC, it is able to predict the skills which are in purple. At the same time, it is also able to predict the red color skills which are missed by the previous model. So we can infer from here that job XMLC is able to model the connections between the jobs and skills and other jobs well, in order to identify the skills which are more prominently occurring across all the job descriptions. So this in this work we proposed a job XMLC framework, and then we also see that job XMLC outperformed by deep extreme classifiers, and in training and predicting, job XMLC is 18x and 634x faster than extreme deep classifiers. Now we are moving towards our third contribution, which is identifying fraudulent content. So among since now we have seen some issues which were the quality issues, and they are, although they are harming the platform reputation, but there is no loss of money or there is no harm of reputation and uh, anxiety and stress for the end user in terms of in terms of content when it is inducing some stress in you. So this particular fraudulent content, it is one of the important issue, not only in the domain of content quality, but in general for the platforms. So the major primary uh, motivation behind solving this problem, uh, we we identified that whenever fraud happens, there are primarily two reasons: that you do not know what is happening to you at the current, means you are very new to the platform and you have visited it for the first time, and you do not know what kind of content comes on the platform. Second, it might be possible that there is a job which has a such kind of content which you think that it is genuine, and you are actively seeking for the job in short span of time, and there is a high chances for you as a beginner or a fresher to click on that job. So in both cases, if you have a domain specific knowledge that for what kind of job, how much money is being offered, or what skills are required for a particular designation, this kind of knowledge will naturally help you identify that what is the content quality of this particular job. Is it genuine or is it fraudulent? So that motivated us to first build a domain specific knowledge graph where we want to capture these kind of facts so that it can pinpoint exactly these are the facts which are present in the genuine jobs, and these facts could actually help in further training of a model which can identify fraudulent or legitimate jobs. So we started with a simple idea where we had a lot of unstructured content, and then we wanted to convert it into some form of structured format so that this kind of knowledge is useful for different applications. When we started with the module, the very first thing when a job comes, a lot of unstructured content, we want to pre-process it. So a job is not only just like a post where we have complete sentences, whether you can visualize a job as a lot of fragmented sentences. At the same time, you have a lot of abbreviations, you have a lot of entities mentioned in it. So it consists of heterogeneous kind of entities and relationships. So we want to pre-process this noisy, unstructured and semi-structured data. Why semi-structured? Because most of the time, the recruiter, they put some content in unstructured form, and at the same time, they put some content in the structured form. So for an example, if I am hiring for a candidate who from IIT or triple IT kind of institutes, then this information I may mention in the structured format, whether I only mention about the qualification information in the unstructured content. So both of these sources need a kind of linking with which we are able to identify that they both belong to same job description. So in order to accomplish this task, first we employed a sentence detection module so that we are able to identify what are the sentences. After that, we revived missing phrases using POS tagging. So revived missing phrases means if we have a fragmented phrases like experience in Python for 2 years. So this kind of phrase we need to complete as a sentence, means we want to have some subject for this sentence so that all the models which can help us to generate the triples, they can perform they perform properly on these kind of sentences. And after that, we also removed HTML and non-ASCII characteristics. So after doing all these pre-processing steps, we exploit rule-based heuristics and vocabulary list to deal with the abbreviations. So this was the simple so to say, a kind of vocabulary that we had, which was populated by the domain experts, that these kind of abbreviations, they come on the platform. So we started with this. So once we had this pre-processing, in the second module, we use POS tagging and NER by using Stanford NLP, flash text, all the off-the-shelf NER and POS taggers. So the intuition behind this is when we use a particular single POS tagger, they do not perform well for a domain-specific kind of data. So therefore, we leverage the advantages, pros and cons of different libraries to finally come up with a kind of hybrid approach, which makes use of these libraries. At the same time, we also use dependency parsing to find the context. Then we use relation and triple extraction using OpenAI systems. So these are the entities. After using all this, we identified companies, institutes, skills, experience, certification, and designations. So once we have this set of entities, we also want to do polarity detection. So for an example, if an entity is mentioned in the text, but I don't want that entity, it means no fresher is needed. So it means I should be able to get that there is negative dependency on this particular entity. And these are the entity statistics. So after doing this exercise, we are from 250,000 job postings, we are able to get 5,220 unique relationships using OpenAI method, and then more than 365,000 entities. And these are the total number of the relationships. This is how the graph looks like, where you have you can see there is a designation uh, in the center, which is data analyst, and all the jobs which you see in the sky blue, they are linked to the data analyst job. And finally, the skills, experience, qualification, these entities, these are linked to the designations as well as the job at the same time. So in order to evaluate this framework, because we are creating it from the unstructured content, we randomly selected 310 jobs, which consist of 4,719 sentences, and we are able to extract at least 1.72 triples per sentence. And there was also an error due to these extractions, because there were incomplete triples which were written by these extractors, and there were also sometimes no triple which is being extracted from a particular sentence. Finally, our evaluation metrics were, we got 82% precision, 68% recall, and affirmation. So this brings us that once we have this domain specific knowledge graph, now the question is, can I actually use it to identify fraudulent content? Now let's look at a job description. So this is the job description, two job descriptions, one having data entry clerk position, another having data entry clerk, same designation. If you see the left hand side job, you have some kind of facts which are present here. So it is saying that earning $1,000 to $2,500 per week, and you do not need any special skills to get started. Earn as much as your comfort of home typing, and no experience is required. So you can see it is offering very high salary for no experience. Right? At the same time, a genuine data entry clerk position, it looks like it mentions roles and responsibilities, and it also mentions about how can you what are all the things that you need to do as a part of your job. But it also mentioned that these are not limited to, means there are more responsibilities that you can be given. So if we see both these jobs, we see that fraudulent jobs, these are having untenable facts which are not possible about domain specific entities. So we took this advantage to see that if we have a misleading content which is present in the job posting, literature used content-based approaches, context-based approaches, and knowledge-based approaches to identify such content. But based on these string features, all of these approaches, they ignore factual information which is present in the form of unstructured content. Now, since we have constructed a domain-specific knowledge graph, we took the data set. So we took the data set of a popular recruitment platform, which was being marked fraudulent and legitimate by the domain experts. And then we also identified what are the primary key features that are present in the job, which we used as the meta features. For an example, a fraudulent job, it will have only average words as 70. And the legitimate job, on the other hand, you can see there are 231 words which are present. And so on. These are the entities and the relations which were extracted from these job descriptions. So we started with the data set of fraudulent and legitimate jobs. And after that, we constructed, so this was the job posting. And then we constructed a knowledge base, which are knowledge graphs for both of these two job postings, where we have the label that which are the legitimate ones and which are the fraudulent ones. So from this, we get two knowledge graphs. One is true knowledge graph, another is false knowledge graph, having the false facts. And then we employed knowledge graph embedding representations, which are also called as fact-checking algorithms, to actually find out that which triples are true, which triples are false. So with the fact-based extraction, it is possible that there are certain facts which are not extracted and they are part of a context in the job description. So therefore, we also made use of job embeddings, the entire context of the job. And the third, we also use meta features, which were what is the job length, what is the employment type, part-time, work from home, these kind of features which were important. And finally, we had the collective representations of these jobs to, 1 second, sorry. This is not working. Yeah. No. Okay. So I think it will work for 1 minute. Maybe.
Hours. Okay, let's start.
Sorry to interrupt. There is a battery low.
Yeah. What's up? Okay, what is? Is it working? I think it will work.
Yes, it is working now. Thank you. Yes, so finally we have the collective representations, and once we have these representations, yeah. Okay. So once we have these collective representations, we pass it through the interaction layer and finally the classification, where it identifies that which job is fraudulent and legitimate. So in order to model these knowledge graph, we also use translation-based approaches, different translation-based approaches like TransH, TransD, TransR, and out of which TransH outperforms well for us. So therefore, in our architecture, we use TransH as a modeling technique for fact-checking algorithms. So TransH is able to model well many-to-many relationships for recruitment kind of data, where we have a scenario like there is a designations and multiple skills are required in it. These are our results on, so we can see using only the M1 features, which are contextual, factuals, and meta features, and all three together, it outperforms on proprietary data sets. Similar observations have been done on the public data set. So in this work, we studied a fact validation data sets of 4 million facts, which are extracted from the job postings. And we also propose a multi-tier end-to-end framework for fraudulent job detection. So finally, we come to the end of our last content quality issue, which was low quality contents. So till now, you have seen that there was inconsistent, incomplete, and misleading fraudulent content. The last one, it takes us to the stack overflow Overflow platform, which is a kind of a knowledge sharing platform. So there, so in the middle, Stack Overflow also started with the job. So Stack Overflow Jobs was one of the subsidiary which was started, but now it has been shut down. So Stack Overflow primarily works in knowledge sharing. So Stack Overflow works in knowledge sharing, and most of the recruiters, they also look at the candidate's profile or reputation on the Stack Overflow. Means how do they ask questions, how do they get answers. So Stack Overflow is a kind of a programming website which invites the questions from the beginners as well as experienced users, and most of the moderators, they try to moderate this kind of content regularly. So if you see on my screen, these are the closed questions on the Stack Overflow. So a question is getting closed on the Stack Overflow primarily because of these 4 reasons. If it is off topic, if it is unclear, it is primarily opinion based, and it is too broad. So a person asking the question, why do people hate Java? This is opinion based questions. So this person, he wants to draw more conversations on his question rather than genuinely looking for the answer. So these are the guidelines that Stack Overflow and knowledge sharing websites regularly issues, that how should you ask a good quality question. And in their guidelines, they include that you should first use relevant tags, which are the tags that will identify your question, and it will push your question towards the community who is the expert of particular question. So for an example, if you're asking a Python question, you should definitely have a Python tag in your with your post, so that it can be recommended to the Python experts. So what are we trying to do here is we are trying to act as an early intervention system, where can you actually nudge a user before his question gets closed, saying that these based on these features your question is trying to get close to. So towards this end, we constructed a framework called as LQuad, which will detect the low quality questions which are likely to get closed at the time of posting. And then our framework also act as an early assessment tool, which will help the users in composing the questions, and also telling them the cues that how could your question remain open and receive responses on the platform. So we will look into the architecture called as LQuad. So we start with the Stack Overflow post. A Stack Overflow post has 3 components: title, body, and tags. In the title, you have the heading, the main header. In the body, you ask that whatever programming question you want to ask. And tags, these are this you should definitely include, so that your question is identified that which category it does belongs to. So Stack Overflow has already set of list of tags. At the same time, you can also propose new tags to the Stack Overflow website. So most of the tags, so when we took this title and body data, concatenated it together, and used the pre-trained BERT overflow model, which was trained on millions of documents from the Stack Overflow platform. And finally, through the classification layer, we made the predictions about this post, whether it is closed or non-closed. Then we also took the tags data. So these tags are linked to these posts. So when tags are linked to a particular post, it has a relationship with the post, and this particular tag can has relationship with multiple posts. So there we went ahead with construction of a bipartite graph, which will have a post, and it is connected to a tag if that tag is relevant to that particular post. So in this graph scenario, you can have maximum of 6 tags, because Stack Overflow restricts that your how many total number of tags you can put on a particular post. So when we have this graph, after that we posed a node classification task, and based on this, we had the predictions out of this. Taking together both the semantic property and the structural property, which is learned by the graph, we use a late fusion mechanism to actually predict that whether your question is going to be closed or not. Yes. Yes. So these are the statistics from on the data. So when you construct a graph, there were total of 28,51,838 nodes, which were being connected with unique tags of 48,000 plus, and total number of train and valid samples. So we can see that total non-closed posts are naturally 10 times more than total closed posts over the platform. Then in order to examine the known content, so these were the content related characteristics where we, using the content, we are trying to identify that whether this post is going to be closed or not. Now, Stack Overflow also has non-content related characteristics, which means, let's say if a post which is very popular, you can give upvotes or downvotes to that particular post. And also you can answer on that post saying that this post should remain open, and when a post get closed, it is flagged by the reason by the moderators. That's why most of the time newbies who comes on the Stack Overflow, they also face anxiety and prominently ask questions saying that why my question gets closed on the Stack Overflow. So when they tag with specific reasons, we took that data of all the reasons that it was marked closed with. So we took off topic, unclear what you are asking, to broad, primarily opinion based, and also the tag categories which were closed by the Stack Overflow moderators. After analyzing this data, we find out mean survival time and mean time till event of interest, means till the time it get closed. We see that primarily opinion-based questions, these remain open for a longer duration as compared to unclear what you are asking questions. Similarly, the question with tags like cloud and other frameworks, they have higher mean till event of interest than other categories. So it clearly shows that these kind of tags which remain relatively open for a longer period of time. So the reason is that primary opinion based questions has a lot of conversation on it, therefore it remain open for a longer period of time. This is the temporal event analysis. So based on these questions being open for a longer hours, we can see that there is a 22% probability of being open beyond 100 hours for the question which is unclear what you are asking, and there is a 42% probability of being open after 100 hours if a question which belongs to a primarily opinion based question. Right? So therefore, based upon these analysis, user can get an idea that what are the most why their questions is being closed so early and why some questions are being closed later. So these are our experimental results on the LQuad. We can see that it outperforms as compared to distilled bird, count vectorizers, which were handcrafted features, and GCN based techniques. These are the visualizations where you can see the closed questions and non-closed questions. These are kind of communities in the entire network of Stack Overflow. In the ablation study, we found that both the modules, they are contributing during the late fusion. Module 1 and module 2. Module 1 was the contextual module and second was the structural module. So this brings us towards the end of the content quality issue, which is the low quality. We proposed a LQuad architecture, and it can act as an assessment tool by composing a question. At the same time, it is also informing the users about the known content related characteristics, and it outperforms all the state of the art methods with 21% in F1. These are the conclusions. We developed a multi-tier framework called as KCNet for handling the issue inconsistent content. We also developed a job skill graph and JobXMLC to handle the incomplete content. And then we further on created a domain-specific knowledge graph Con2KG and an architecture FRJD, which helps you identify misleading content by marking fraudulent and legitimate job. And finally, we want to deal with the low quality content where we proposed LQuad, which takes in account the semantic and structural information using GCM. So this helps the Stack Overflow or a knowledge sharing platforms to identify low quality posts on their platform. So these are the publications out of these work. Finally, I want to express my gratitude to precoggers, all the precogs, PhD students, undergraduate students, master students, Cracker Lab, Gunjan, Monica, Aisha for reviewing the slides, and Triple IT Delhi admin, and all the friends whom I met. Thanks to all the collaborators, especially InfoEdge India Limited and analytics team. InfoEdge India Limited was the primary industry collaborator as a part of PM fellowship. And then I would also like to thank Anmol, Jishan, Udit, Tanuj, Dr. Siddharth, Dr. Charu, Dr. Radhika. And thanks to my internal committee members, Dr. Rajiv Ratansha and Dr. Arun Balaji. And thanks to all the companies and the industries who played an role to help me in conference travels. So acknowledgements to Sir, Piki, Triple IT Delhi, InfoEdge, Cracker, Precog. Thank you. Thank you for your attention.
Okay, thanks, Nidhi. Now, meaning if there are people